I had to stop talking about a technology and start talking about a business. And what is the opportunity? What is really the problem that we're solving? And is it a big enough problem to solve that people are going to buy it? Is it a big enough problem to solve that investors are going to see a return? I've lost track of how many pitch decks I've made these days, but going back into the early days, it was very much a technology focused pitch. And it was through that year of 2017 when I was pitching to investors and to organizations. And I hadn't yet gone through an accelerator program, so I'm taking it from an academic lens and nothing's landing. And sometimes I'd get, that the feedback was always very pleasant. Oh, that's very interesting. Come back to us a little later, right? But I finally got a couple folks who were willing to say, "Here's your problem. You're not talking to me about a business. You're talking to me about a technology."
When we think about electricity, we usually think of wind turbines along the highway, power plants with their big smokestacks, and solar panels on our roof. And so the concept of harnessing electricity from bacteria seems like science fiction. After working at Raytheon digitizing missile guiding systems, Orianna Bretschger realized that she wanted to do work that would benefit the planet and the people on it. So after some soul searching, she landed in a materials science PhD program at the University of Southern California. And it was there that she, with a chance encounter, met the man who had discovered a bacteria that could not only produce electrons, but conduct them. That was at the height of the renewable energy boom in the early 2000s, and the potential to cultivate these bacteria and extract electricity from industrial wastewater was way too good to pass up.
I was fortunate to work for the man that did discover Shionella onidensis MR1. So his name's Ken Nielsen, and he was an inspiration in so many ways. So I started off in engineering, right? Material science, and I was doing material science research. But he came in and he gave a lecture to cohort. And this was my first year. And he started talking about how bacteria breathe rocks and generate electricity and do all of these absolutely amazing things. And so my mind was blown. And literally the next day, I went to his office and asked him to take me on as a grad student, even though he was from the biology and earth sciences department. And so they worked it out between engineering and earth science biology, where I was able to do a majority of my research in his lab, but still finished with the engineering degree because I was looking at that interface of how biology electronically interacts with the surface. And so the work that I did in supporting Ken's, lifetime work really was really trying to figure out with a set of different mutants that we had of Shionella onidensis, what were the specific genes and mechanisms associated with moving electrons between the bacteria and the surface that they're interacting with, whether it's iron or manganese or an electrode. And what we found in that is that it's different. So, an organism is going to react differently in that electron transfer reaction in the environment with iron and manganese than necessarily on an electrode, which is kind of an artificial stand-in, right? And so that, kind of got wheels turning. And Ken and I talked a lot about what's a practical application for this knowledge base. And at the time, the research area, and we certainly were not the only labs working on this. There were many across the world that were studying the different types of bacteria and their function and putting them into this context of an applied use case, which was wastewater treatment, but more from the energy recovery perspective. So, a lot of folks were looking at this as like, how much power can we get out of these things? And Ken and I always kind of like, well, it's a biological system. It's not incentivized to give up a lot of energy, right? And so we looked at it more from the water perspective of if you can electronically control bacteria, now you have a whole other mechanism for, driving efficiency and, controlling biological treatment outside of mixing and aeration and, the conventional mechanical mechanisms that have been in place for decades. And so that's really the spin that we took. And that's how Aquacycl came to be.
And so you defend with kind of starting just with Shuanella, and then it appears that you keep going with this research, but this time at let me pull it up, the J. Craig Venter Institute. And it's there where you produce a number of other papers, and you work as an associate professor, again, building off of this work, and now this time with microbial fuel cells, what you're talking about, truly harnessing the energy that these bacteria are creating in a way that you can actually use it to fuel the system. And that blew my mind as I read about it. And so I guess tell me more about your time at the institute and the work you did. It seems to be the place where Aquacycl really came together, or at least the idea of your modules really sort of took form and were tested on a lab scale.
Yeah, that's very true. So, in the grad work, it was one organism, one bug. How does it do what it does, right? And we're using little devices that are about the size of a coffee cup, right? So, and are all glass and hand blown. Very very lab. We go to the J. Craig Venter Institute, or JCVI, and Ken was very much involved in the work that was happening there. But it's a genomics institute. And Craig Venter is one of the scientists that was working on the human genome project, and actually raced the federal government, right? And it was called a tie, but ultimately, right, his work led to the first human genome sequence, and sequencing of a lot of other organisms across the world. And so his institute was very much focused on how do we use genomics to solve big problems, right? And so I was able to come there and look at the water problem specifically, and still, with this microbial fuel cell concept, instead of one bug that we kind of know a little bit about, what happens when you have a community of organisms, which is the reality of our environment and the reality of wastewater treatment. You have all these diverse different types of organisms that symbiotically work together to run a process. So we did a lot more fundamental science, taking these genomics tools, metagenomics, as well as metatranscriptomic tools, to look now at diverse communities and how they are reacting, genomically and functionally, to the environments and environmental challenges. And so I had an amazing team of researchers that we all worked together, and started to ask some of these fundamental questions, utilizing microbial fuel cells as a tool to do that. And as we started to ask more questions and get more data, it really kind of became clear, like, this whole concept of electronically controlling a community of organisms could really work. And so I wrote a lot more grants, and we got some more funding in to explore the more practical side of that. So, okay, we got this fundamental knowledge, and we're learning more and more. So, how do we now develop an actual system, an engineered system that could take advantage of what we know now? And so, my group was kind of onto both sides of the coin, very much fundamental science, and then taking that and applying it now to technology development. And so that was, yeah, about 8 years. And we got to a point, I think it was 2013. Um, we had the opportunity to meet the Roddenberry family. Um, Gene Roddenberry's son started a foundation, the Roddenberry Foundation, and they really were focused on helping to fund research that can solve big problems, right? And so we were able to connect with them, and they are avid scuba divers and very focused on how to improve climate and, water health, ocean health. And so they ended up funding my group at the institute, a $5 million grant, to take what we had done in the lab and apply that, right, into some field case studies. One of those pilots was like the first out of the lab, well, second out of the lab pilot that we did, I should say, um, was at a pig farm in Escondido, California. And that system's still running. But that gave us like our MVP, if you will, right? Our first product that really seemed to work and was reproducible, and it was working outside of the lab in more of a real world context. Then we took that same design and we put it into Tijuana as another pilot because that was one of our milestones is how could we deploy this internationally. In San Diego, we've got the great benefit of, being right there on the border with Mexico. And so we found some partners that we could work with to test this from a residential and sanitation perspective. And that pilot went pretty well as well. So with these use cases, right, we came back to the foundation to say, all right, we've hit the milestones, we've spent the money. Now what's next? And there's, a potential that there could be a business use case here, but we can also continue to develop it within the not-for-profit space and go further through philanthropic and grant funding. And really, they made the decision for me relative to spinning out. And they came on, they said, go forth and make a company. And I very naively said yes. And they came on as our first investor. And that was at the end of 2016. So like November 2016 is when Aquacycl was born.
Okay. And so you have these two pilots in Tijuana, the other in Escondido. And, you mentioned all the grants. You clearly got quite a lot of practice at pitching yourself because fast forward to 2019, you go to the San Diego Angel Conference and you win. You win the cash prize. I'm kind of curious what happens between those 3 years.
What I was doing and still do was drinking from a fire hose. So writing grants and, working in a soft money model was good preparation because I have to track all the money. I need to know how we're spending. I got to make sure I've got enough, grants out in the pipeline to secure funding and keep us going as a group, right? So that practice was very helpful. But raising money through federal funding or foundation funding is extremely different than raising investor money. And that lesson was hard learned throughout all of 2017 and a good bit of 2018. I am a recovering academic, right? And I had spent many years really talking about the research and the tech and how cool it is. And when you're writing a grant, you've got a federal grant, you got a 15-page proposal plus all of the complementary documents. But in that 15 pages, you got maybe one paragraph, right, that talks about the broader impact. This is the commercial opportunity, right? And so you can, okay, yeah, this could turn into business and it could solve the world's problems, right? All of us kind of take that lens in writing a proposal because we haven't really thought about what does it take to make that business? What is the product? Who's going to buy it? How is it going to be a business, right? We just think about the technology and the problems that the technology could solve, but not necessarily the how in between those two things. And so that was a big learning. I had to stop talking about a technology and start talking about a business. And what is the opportunity? What is really the problem that we're solving? And is it a big enough problem to solve that people are going to buy it? Is it a big enough problem to solve that investors are going to see a return? And, I've lost track of how many pitch decks I've made these days, but going back into the early days, it was very much a technology focused pitch. And it was through that year of 2017 when I was pitching to investors and to organizations. And I hadn't yet gone through an accelerator program, so I'm taking it from an academic lens and nothing's landing. And sometimes I'd get, that the feedback was always very pleasant. Oh, that's very interesting. Come back to us a little later, right? But I finally got a couple folks who were willing to say, "Here's your problem. You're not talking to me about a business. You're talking to me about a technology. So here's the things that you need to do." And one of really the very transformative opportunities for us actually came through one of my neighbors who is an entrepreneur. And she's like, "Hey, San Diego has a startup community and there's this whole startup week that happens once a year. This is pre-pandemic. And so entrepreneurs come and share ideas and they do pitch competitions. And it's a good way to connect with people who are doing the same thing and get that feedback." And our first pitch competition was at a San Diego startup week. We had very little cash in the bank at this point, but I was like, okay, the whole team needs to go and learn how to make a business. So we all spread out, and they had, different forums and different groups, and it was spread out throughout San Diego. And everybody went, took notes. And we took second in that competition and got some great feedback. And one of our first investors, actually, I met there. Uh, So that was a good eye-opening experience, and some very thoughtful people who kind of sat me down. It's like, here's the 10 slide deck that you need to start thinking about, right? And these are the questions that investors are going to be asking and thinking as they're hearing you. Then the other transformational part in the process was we applied to and were accepted to the Imagine H2O program. And that was in 2018. And we were in their 2018 cohort. And that was pivotal for us. Really awesome mentorship, specific in water, understanding the water challenges with water customers and water investors, and really helped us craft, right? Not only a story, but really think critically about the business and how the business can grow. And where is our beachhead market? And how are we going to grow within that and then expand outside of it? How are we going to best communicate that? And so hugely transformational for us, and also brought in some board members and investors, right, from that experience. And we went through several other accelerator programs, kind of different focus, right, but growing the network. And that's really how we viewed the accelerator community, as we can different touch points, different types of clients, different types of lenses that helped us both expand our network, but also, kind of hone in on that story. And so by the time we got to the San Diego Angel Conference, we we'd already gone through one of our first commercial pilots with a huge name confectioner. We had already had a potential deal with a brewer in Southern California. And so we had that attraction. We had some proof points to put behind why this is going to be a successful business. And so that led to us continuing to raise money. Um, the other thing that the foundation, as our first investor, did very well for us, and I didn't realize it at the time, but they set their first investment as a match. So they committed $1 million, but they only released 250,000. I had to raise another million from outside investors before they would release the remaining 750. And I had a timeline to do it. But because I had that commitment, right, and because I had that timeline, I was able to create the excitement and the momentum on the fundraising path to to hit the match.
Oh my gosh. And so, no, that's a pretty crazy story. So again, you're kind of thrust into entrepreneurship, and the first year is rough. And I think I see this a lot, like in my work, just technical people struggle to translate the impact and understand the business aspect. And so you learn on the fly, and you kind of have a lot of first dates, and if you will, and really learn how you need to flip what you're talking about, but it sounds like you figure it out, especially with IH2O as an incredible program, and getting into that cohort was probably very pivotal to you guys being successful. And so you get the angel money. It's $200,000, I think. And it seems like in 2019, that's when things really kick off for you guys. Which, all things considered, from 2016 to 3 years is pretty fast for you to kick things off, right? Especially in the water industry, because tell me if I'm wrong here, but soon after that, you establish a Dutch headquarters in a town called Leeuwarden.
Yeah, so we actually formed our Dutch entity in 2023. And there was a few reasons as to why. For one, as we started really exploring market opportunity and scale, our beachhead has been in food and beverage and in the industrial sector. And our first commercial contract was actually signed during the pandemic, believe it or not. Uh, but as we started to learn more about that client and the problems and the challenges in that market specifically, it led us to Europe, because the regulatory environment there, most especially with the directives that were launched in 2020 and then approved in 21, with more adoption in 23, and then the penalties coming in 25, it was going to be clear that if we set up some offices early on, start to build some relationships, some partnerships, a presence. By the time the penalties start rolling out 25 this year, we have some proof points, right? We are not necessarily ahead of the game, but at least we have an operating entity where we can be supporting in the European environment and start growing those European partnerships and collaborations, which we've been able to do. We haven't put a lot of funding into growing that part of the business yet, but the year is now, and now kind of with the macroeconomic conditions we're all experiencing, very glad we did that when we did. Is that now we have also already set up, right, a network of opportunities, not only in sales but also in manufacturing, right? And the opportunity to be able to, okay, if we have to look at cost reduction and savings right now, we have a Dutch entity that we can flow through and we can do more manufacturing in Europe, which will bring costs down relative to what they are now, importing some of the things that we must import at this point in time. It was ambitious and it was early, but it was motivated by the regulatory environment in the EU and the timeline that they had publicly disclosed in terms of this is what's going to happen. And so the Urban Wastewater Directive and the Industrial Emissions Directive were the two that launched in the early 2021, 22, with the penalties rolling out in 25. And that focuses specifically in industry and is being felt. And, we're starting to see a lot more inbound now relative to some of the challenges these industries are facing.
I'm sure. Going back to what you were saying, food and beverage is your beachhead. What were those problems that you saw? I'm curious. What were the problems you were seeing that you've now continued to kind of gear your business towards solving?
Yeah. So the technology was developed right under the granting space, right? It was developed specifically for sanitation. We wanted an off-grid, off-energy grid, off-sewer grid solution for sanitation, and that's why we developed it. That's how we tested it in the beginning. But it became very clear as we launched into a business that that was not going to be the business we could make money in quickly. So it's still our North Star, right? Our mission is sanitation for all. However, in order to get there, we had to have an early paying client. And so when we started researching where are the problems that we can uniquely solve, we wound up with this confectioner, again, through the network of investors. And uh, we were able to connect with a specific problem where this confection organization was generating some very, very concentrated wastewaters. Every time they clean or candy coating kill, they generate what's called the sweet water. And it's got color and a whole lot of sugar. And they had to land apply this. It could not go into their existing treatment plant, which they had on site. And the city certainly wouldn't take it. And so they asked, well, hey, could you guys do this? And we should. Don't know, but we'll try. And got this sweet water and we tested it. And sure enough, we removed the color and we removed a majority of the sugar. So it could then be discharged into their existing treatment facility and they could eliminate this hauling cost, which was hefty. And so they were the ones that actually did the first pilot with us, commercial pilot, and where they paid for the demonstration. We did this, we installed it toward the end of 2019. The results looked amazing. And then we all know what happened in March of 2020. So we were able to present the results and, to demonstrate that, the proof of how the system could work for them. But it also opened up our eyes to what the industrial challenges were because these guys weren't the only ones experiencing it. And so now we knew that we had a niche as a technology to treat the concentrates. And instead of having to install a huge anaerobic digestion facility and still blend to dilute these concentrates so the AD could work, now we can just take them straight. Small volume, high concentration, big cost to dispose. And so then we started really focusing on that. And it turns out beverage producers, snack producers, distillers, breweries, anybody who's really dealing in production with sugar or starch generates these types of streams. And the solution to pollution has been dilution, right? That's been the motto, right, for decades and decades. But now, with what we know we can do, you can segregate these highly concentrated streams. Majority of your flow out of a given production facility is really pretty clean because it's mostly wash water. So if you take that, little stream out from your first rinse of a cleaned in place process and you send it to us and we treat it, now anything that you already have installed can operate with 80% less energy footprint and a 70 to 90% less sludge footprint in terms of generation, just by treating these little side streams and segregating them and treating them. And so some companies have already been doing that. And that's what we're doing for PepsiCo, right? They've already separated out these high concentrate streams. If they sent them to the city, the surcharges were sky high. So we went in, we just treat that. But now we're starting to help our clients figure out, how do you do this in the production facility? Like, it doesn't have to just be returns or bad batches. Now we can think, and we're starting to do this on a consulting basis. Okay, let's isolate the problem in production before it even hits the floor drain, right? Then let's capture that, send it, treat it. Now you're dealing with a much different challenge from a wastewater management perspective.
And you got ahead of me because I wanted to bring up PepsiCo. And so it starts off with this confectionery manufacturer, and that's where you guys stumble upon, oh wow, industrial wastewater is nasty, and there's real, effects to be made in terms of their bottom line. And so you find your moneyed customer, and it looks like in 2022 you officially partnered with PepsiCo in Fresno to help them figure out what they're going to do with it. Sounded like return soda as well as that. And from what I read, you guys eliminated, I'm seeing 346 tons of carbon dioxide every month with this, as well as 124,000 kilowatts saved by the city because they no longer had to treat all of this up. Yeah, the results really speak for themselves. And give me a sense, what's the footprint of your technology that's accomplishing this for them?
That single 40-foot shipping container. And so, yeah, and we're the operators, so they don't have to touch this container, right? We do this as a service, and we report these savings, so that directly applies to their scope 3 challenges, right? And so, yeah, they've been an amazing partner. We signed our first pilot agreement in 2020. We installed the pilot in 21. We proved it out, and then began operating commercially in 22.
You touched on it a little bit, but how has that partnership grown? Have you gone to new facilities? It sounds like you're doing other applications at that plant.
So they're a great company. They're forward looking. They are willing to try, new things. But they're also a big behemoth, right? They're a Fortune 50. So, and a part of those big enterprise relationships is you've got people coming and going. You've got, promotions and retirements and all the things that play into who's your advocate within the organization. Where else can we expand to? Because, they have, I don't know, hundreds, if not thousands, and some, if you include warehouses of facilities that they own and operate worldwide. And so from a production standpoint, right, they have 300 different facilities. And then if you bring in the snack food, right, on the Frito-Lay Walker side, right, it's a massive footprint. And so we have been able to expand into other production facilities. We have also been able to prove out our second product, which is sulfide fix, and deals with hydrogen sulfide, minimizing that. And we're helping, we're doing more consulting work with them as well, and starting to develop the relationship on the snack side. So they've been amazing, but in terms of speed, the tortoise wins the race, right? But I would say not the fastest moving, but that's not unique to PepsiCo. It's just working with big organizations that you gotta be patient.
Absolutely. So you guys did come out with a new, and I believe it's a microbial fuel cell as well. The The sulfide fix?
It's biologically based, but it's not a fuel cell.
But it's
We don't
not
work
in a okay, okay. Tell me more,
recovery on.
how did that come about? H2S is a big conversation in wastewater, but I assume, did you see that on the floor, just with customers and try to figure out, "Hey, how can we solve this problem for them as well?" How does it relate to the work that you guys were already doing?
Yeah. So hydrogen sulfide was a problem for us. So on the first pilot that we did with municipal wastewater in Tijuana, there's a lot of sulfide that came into that system, and it wasn't working as well as we knew it could. So we had to come up with a cost effective on the fly way of dealing with the hydrogen sulfide. And as a part of our kind of market exploration, we got connected with a dairy farmer in out in Imperial Valley, in just east of San Diego. And so we went to talk to him about, potential opportunities to help them out with manure management. And it turned out, he already had a soft cap anaerobic lagoon. And he was really interested in the energy recovery side of things because with that lagoon, yes, he was making methane, but he had so much sulfide that his blades got eaten out when he was trying to actually run cogen, his equipment just completely corroded away in a matter of months. And so, we started talking to him about that problem. He told us, it was like, yeah, the only way I can really deal with the sulfide is I can pump some air across the surface of the water, and that helps reduce some of the sulfide, but not enough for him to really be effective at the cogen. And so that got us thinking. It's like, okay, so what's that reaction? How does that help? Why does that help? So putting our research caps back on, we started to explore what is the biochemistry that is happening in those ponds, and why would just air across the surface of the water help at all? And well, turns out if you've got enough oxygen tension at the surface of the water, you can start to enrich for hydrogen sulfide oxidizers. So these bacteria live at the interface of the water and the air, and they will consume that hydrogen sulfide gas as an energy source and reduce the oxygen at the surface of the water. And they take that hydrogen sulfide gas and they convert that into elemental granule sulfur, which stays bound in the biomass. So you can take a big volume of gas, convert that into a very small volume of solid biogranule. But what makes that work is you got to have the right oxygen tension at the surface and consistently across the surface. So as we were thinking about this, it's like, okay, well, what about a floating air manifold? Instead of pushing air into the water, which is what a lot of solutions do to try and prevent the sulfide from evolving at all, let's just create a uniform oxygen tension. Saves the energy, gets the right bugs in the right place. So we trialed this first in beverage, and sure enough, the trial went great. We had a 90% reduction of pilot phase, and then we installed it in the underground basin, and it was a 99% removal, and that's been consistent since 22. So no chemical addition, low energy. That's been very good.
That's fascinating. Oh my gosh. And so, okay, going into sort of the present where you guys are now, so you have this new product out. And I saw that in June of this year, you won another pitch contest in San Diego. Is that correct?
Yes. Yeah.
And that's exciting. So, you're still up to that. I saw that you guys are now partnering with EPC firms, engineering, procurement, construction, in case anyone doesn't know what EPC is, but you're creating partnerships. You also recently expanded to is it 8,800 square foot facility now for increasing your manufacturing capabilities?
Yes. Beginning of the year, we had the opportunity to capture some more warehouse space. So we are already in the 11,000 square foot facility, office and warehouse, and with a lot of projects in the queue that we were not going to be able to execute unless we had some more floor space. So as it turned out, there's a great space that opened up literally across the street from our headquarters. And so we signed a lease for an additional 8,000 square feet of warehouse space, which has been great, very, very much needed. The team is way happier. So that's been good. Yeah. And then the focus for us now really, so we've been direct to client in terms of sales, and that's good. But as I mentioned before, right? big companies who we sell to move slow. And so in startup world, we need a little bit more speed, and that really can come from collaboration and partnerships. And so, our clients work with a lot of different engineering firms. They're consultants. They're looking for ways to solve problems. And so if we can partner, with these organizations that are already serving the same client base, um, we can both, grow our business with these clients, right? We can complement projects, help expand the business, with the engineering group, as well as expand our.
And that seems to have worked really well for you guys because, according to the numbers I saw, you guys have increased your revenue by 30% year over year. I'm not sure how many years, and maybe you can tell me, but I mean, that is incredible. Yeah, tell me more. I mean, how is that? How have you managed that much growth? I'm curious, because I saw that and I was like, my God, that is so much happening again with the expansion of your facility, the partnerships, and then just the revenue coming in, and you're partnering with Ecolab and I think other really big companies. Just how are you managing that? How are you continuing to step up? You have held so many roles, from this being a real small startup to, I mean, really becoming a larger and larger business, and obviously that role changes. Just I'm curious how you've continued to step up into these roles as the business has developed.
Well, I'm still learning, right? It's still a fire hose that I'm drinking from. Because with every different stage of the company, and we're 9 years old in November, you've got different challenges to meet. And I've been very fortunate to work with amazing team members over this whole course of my career, right? Whether it's academic or as Aquacycl. My co-founders and I, we're both recovering academics, right? She's the chemist, I'm the engineer. And we've worked together since 2012, right? So before we launched Aquacycl, for different institutes. We published a paper together. She came on to JCVI and we launched Aquacycl out really together. And so I'm very thankful for her as a partner, and very thankful for the team members that we've had. Some of our team has been with us. I mean, our longest term team members, 7 years. So 7 out of 9, not bad. And so, and it's been also really cool to see the evolution of our team as well. So those folks that have been with us for multiple years, maybe started, we've got one member who started as an intern, is now our director of R&D. you know, um, uh, our, our, our CAD designer started really as just one of our first technicians, building stuff out in the manufacturing plant, and they've gone through school, and now they're doing CAD design for us. And so it's been very cool to see people grow in their professional careers, as independent, as individuals, but also to grow with us, right, as a company. And we all have to wear a lot of hats all the time still, right? I I'm pretty much overseeing all of the sales and marketing efforts. My co-founder oversees a lot of almost all of the development and technical execution on projects. And so that's how we split it. So I take care of the money. She takes care of the technology. And so, we run our groups very collaboratively across, those two objectives. And so, yeah, there's growing pains, there's difficult decisions to be made, there's, the day-to-day challenges. And I think as founders, that's the thing that we all have to come to terms with quickly, is how do we emotionally regulate, right? There's a lot of high highs and low lows, but you have to keep a pretty even keel, throughout all of it. And that's impossible. We're all human, right? So there's things that maybe don't get handled in the best way always, right? But you learn from that, and every mistake you make, you learn something from. And so we try to build that culture of, all right, we got to fail fast, learn from those mistakes, spend as slowly as possible, and grow business together.
Beautifully said. So for my final question, what's the future for you guys? I see that now that the the EU Industrial Emissions Directive, the Urban Wastewater Directive are in full effect, and it sounds like you're pretty bullish on Europe. You're also continuing to work with Mexico, which is sort of a callback to your work in Tijuana. But what else? Do you have more products you have your sights on that you'd like to create? Do you have just more markets, maybe Asia? I don't know. Where are you guys going next?
Yeah. Well, domination, wastewater treatment, naturally. But as new products, we're always learning, client challenges. And so we keep that product development hat on, through our sales process of, okay, how else can we help? What are the things that they're facing? And, as we move into this era now, right, with data centers becoming the massive water consumers, how is that going to impact our clients and their water use case and their water efficiency requirements, right? Because everybody's drawn from the same basin. And then that also brings in some really exciting opportunities relative to reuse, right? So putting us on the front stack of a zero liquid discharge solution means that everything that's plugged in after us operates with less energy, less maintenance, less sludge. And so as the world starts to move, and as the industry starts to move into more of a ZLD or, minimal liquid discharge solution, that's where we see a lot of growth opportunity. We're always optimizing our products to be able to provide, right, that fit and easy integration with other technologies to make that happen. Of course, we also are excited about, the AI revolution, because now that we have all these data sets and we're already measuring electrical signals from everything. So now it's a matter of machine learning and reducing operator time and travel time, because the system can run itself. And so, you know, we're starting to do some of that training, and in the more systems that we roll out, the better the better the training is, and the more efficient that process becomes, which is super exciting. We get a lot of inquiries from Asia Pacific. We're still a pretty small team. We're scrappy. We're 26 people, and we operate in Mexico, the Netherlands, and then in Colorado, Texas, California, and Nevada. And so um, we've stayed pretty lean for what it is that we do. We have to stay very focused and making sure we can hit those growth targets, right? Yes, 30% year over year in revenue is great, but we still need to get to the next, we want 10x, we want 100x, we're looking for, uh, the next best places where we can have an impact, in a positive way for our clients and for the industry. And of course, our investors and our team. So, the vision is Asia Pacific. Our next office ideally would be in Singapore, and that'll be a few years off, right? But being able to also work in the industrial space there. But industry is a big, broad term. So if we say we're industrial wastewater, our beachhead has been food and beverage, but we've got some really exciting results from chemical remediation as well as petrochemical. Dealing with really tough stuff, things like benzenes, toluenes, MEKs, diesel, gasoline. Our system does very well in removing these things to below detection limits. As we start to look at different market opportunities, we see pharmaceutical, we see chemical, and we see petrochemical as really the next huge opportunities for us in terms of market.
Wow, that was all really exciting in terms of the machine learning and potentially having them be lower and lower maintenance, and then as well as I'm interested. So there's bacteria that will break down benzene that develop in these systems and continue to really, wow, that's incredible. I mean,
And it's the same tech and it's the same system. It's just
really,
we set up an environment to select for the right bugs that are adapted to remove these chemistries while still generating that electrical current, right? Because that's the selection process. So yeah, we've got great results. I mean, the low detection limits with the standard deviation of, it was just insane how well the system did with benzene and toluene as well. And some of these really challenging aromatics and long chain hydrocarbons. And so super excited to get commercially operating in those industries.
That was Orianna Bretschger, one of the co-founders of Aquacycl. I think one of the reasons I started this pod is because I really enjoy meeting people who are so creative in technical spaces. The creativity it takes to be competitive in academia is the same spirit of what it takes to be an entrepreneur, whether it's raising money, understanding the angles of what makes your project or your product attractive to buyers. Aquacycl has so much potential to clean the world's industrial wastewater in a way that doesn't need electricity from power plants or solar panels. It's a game changer, and it really changed my perspective on how we generate power. I hope you enjoyed this episode of The Meter. Stay tuned for the next episode.